All right, now that we saw standard form a little bit, let's practice graphing quadratic functions in standard form. So graph each function. What are the axis of symmetry, the vertex, and the y-intercept of the functions? So here's part A. We have f of x equals 2x squared plus 4x plus 3. Let's go ahead and identify our A, our B, and our C values because we're going to use that to find some of the information below. So your A value is the coefficient of the x squared. We see that's a 2 with the x squared. The B value is the coefficient of the x, so that's just a 4. And the C value is the constant term on the end. This will be the number that does not have an x. So your C value is 3. All right, first thing we're going to find is the axis of symmetry. Axis of symmetry has that little formula we wrote down in our intro video, negative b over 2 times a. And now we're just going to plug in our values and simplify. So we have a negative, and then I always do a parenthesis for plugging in b. I look up above, I can see that b is a 4 over. Now I want to take note, sometimes, because the negative is part of the formula right here, sometimes you end up with a negative negative. So that will turn positive if they were both negative. They're not in this case, but just be aware that that happens sometimes. All right, over 2 times our a value is 2. So we have negative 4 over positive 4, which is negative 1. We do want to write our final answer out as an equation of a line, x equals negative 1, and there is our axis of symmetry. So we go to our graph, we can go ahead and sketch in the line at x equals negative 1. It's that vertical line that's going to go through the x-axis at negative 1. All right, next we're going to find the vertex. What we know about the vertex is that the x-coordinate of the vertex uses the negative b over 2a. Well, we just did the work of negative b over 2a, and we got a negative 1. So when you find the axis of symmetry, you also have the x value of your vertex. So keep in mind that axis of symmetry and the x-coordinate of your vertex will always be the same number. Now to get the y value, we'll go ahead and plug in that negative 1 to the function. We have 2 times negative 1 squared plus 4 times negative 1 plus 3. On these, just grab your calculator, type it in exactly as you see it, but you have to make sure you are typing in these parentheses, otherwise you won't get the right answer. So when you type that in correctly with parentheses, we get a positive 1. So our vertex is at negative 1, 1. So let's go ahead and put that on our graph. Negative 1, positive 1. There's our vertex. All right, step 3, the y-intercept. So we learned that the y-intercept is your c value. So our c value is equal to 3 from up above. So the y-intercept is that ordered pair 0, 3. So let's go to our graph and plot a point at 0, 3. And anytime you have a point on your parabola on either the left side or the right side, you can get its reflection point. So what that means is, these graphs are symmetrical. That's a symmetry line going down the center. So this point up here at 0, 3 is 1 unit away from the axis of symmetry. So I can go 1 unit on the other side, and there's its reflection point. So the y-intercept actually gives us 2 more points on our parabola. All right, so step 4, we're going to determine our graphing pattern. Graphing pattern comes off of our a value. We already said a value is 2. So we're going to take our a value times the 1, 3, 5 graphing pattern. So we're going to do 2 times 1, 2 times 3, and 2 times 5. So we're going to use a 2, 6, 10 pattern. We can put those over 1. To plot those points, we go back to our vertex. From the vertex, we're going to go up 2 over 1. Up 2 over 1 happens to be our y-intercept. We already have a point there, so that's good. It's all lining up. From there, we're going to go up 6 over 1. 1, 2, 3, 4, 5, 6. It's off the graph, but we can go ahead and sketch that in. It's just a couple off of the graph. And then we would get its reflection point on the other side. And then step 5, draw the parabola. All right, that's how you graph a parabola in standard form. So you can see we have 2 more to do. So we can run through these a little bit faster now that we've talked about it. We'll just run through the steps, get our graphs on there, and the more you do these, the faster they get. So for part B, we have g of x equals x squared plus 2x plus 4. Why don't we start by identifying our a, b, and c values. So our a value is the coefficient of x squared, which is a 1. Our b value is the coefficient of x, which is a 2. And our c value is the coefficient, or just the constant term on the end, which is 4. All right, so our steps to graph a parabola or a quadratic function in standard form. Step 1, find the axis of symmetry. We're going to do that by using our little formula x equals negative b over 2a. So negative parentheses, our b is a 2 over 2 times, so that parentheses a is a 1. We have a negative 2 over 2, which is negative 1. So our axis of symmetry is x equals negative 1. So we go to our graph and we draw in that vertical line at x equals negative 1. All right, step 2, we want to find the vertex. So the vertex has the same x value as your axis of symmetry, so you already have half of your vertex. To get the other half, we're going to plug in a negative 1 to our function and see what we get back for the y value. So use parentheses, negative 1 squared plus 2 times negative 1 plus 4. We simplify that and we get a positive 3. So our vertex is at that ordered pair, negative 1, 3. So let's plot that. Negative 1, 3, is right here. Remember, that vertex will be on the axis of symmetry. So that's good that that is all lining up so far. Step 3 is the y-intercept. Well, the y-intercept is the c value, which we identified as 4 up above. So we have the order pair 0, 4. We got that from our c value being a 4. So on our graph, let's go ahead and plot the point 0, 4. And then we'll reflect it across. So we got 2 points on our graph. And then last, we are going to determine our graphing pattern. That uses our a value, which is 2. So you're going to take that 2, multiply it by, actually, our a value is not 2. Who said that? Our a value is 1. So when your a value is 1, your graphing pattern is just 1, 3, 5. So from the vertex, we're going to go up 1 to the right 1. That's hitting our y-intercept, so that's good. Then we'll go up 3 to the right 1, plot our point. Up 5 to the right 1 is too far off the graph, so let's reflect that point across the other side. And then last, we draw in our parabola. All right, last one. First, let's identify our a, b, and c. Our a value is the coefficient of x squared, so negative 0.75. Our b value is the coefficient of x, which is a 3. And our c value is the constant term on the end, which is a negative 4. So first, axis of symmetry. We do x equals negative b over 2a, so we have a negative, our b value is 3, over 2 times our a is a negative 0.75. So that's a negative 3 in the numerator. 2 times a negative 0.75 is a negative 1.5. And negative 3 divided by negative 1.5 is a positive 2. So x equals 2 is our axis of symmetry. We can go to our graph and draw in that vertical line at x equals 2. All right, after the axis of symmetry, we find our vertex. Step 2. Remember, we have half of the vertex already. We know the x value is a 2. We're just going to plug that in to get the y value. So negative 0.75 times 2 squared plus 3 times 2 minus 4. Using your calculator and typing it in exactly as we wrote it, you're going to get back a negative 1. So our vertex is at 2, negative 1. Now let's get our y-intercept. Y-intercept comes from the c value. The c value we said was a negative 4, so we're going to have 0, negative 4, and I'm just going to make a note. That's because our c value is negative 4. So if we come down here and plot our y-intercept at negative 4 and then reflect it across to the other side, that gives us 2 points on our graph. And then our very last step is we want to determine our graphing pattern. So the a value is equal to a negative 0.75. So you're going to take a negative 0.75 times 1, a negative 0.75 times 2, a negative 0.75 times 3. When you multiply that out, you get a negative 0.75, a negative 2.25, and a negative 3.75. So plotting that, it's going to be a little bit tricky because of and we're going to put these over 1, just because of those decimals, but I think we can do it. Just be very careful. We're at negative 1. We're going to go down a negative 0.75, so 3/4 of the way, and then over 1. That will put us about here. Now we're going to go down a negative 2.25. So here's 1. 2.25 actually gets us back on an exact spot, and then over 1. And that point is already plotted, which is great. And then from there, we're going to go down negative 3.75. So 1, 2, 3, and then 0.75 of the way, so just 3/4 of the way, and then over 1, we can get that point. Reflect it across the other side, and oops, I didn't do the down one to the left 0.75. Okay. All right, there you go. We just graphed 3 parabolas in standard form.